Erica Windisch is a founder of a company doing serverless stuff. And yes, of course, blah, 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 there are servers, sure. But the way that we're interacting with, interfacing with, and managing services and servers is, as you know, changing. And some of us, it's bright enough in here that I can't see how many of you are as old as me, so I'm going to imagine that some of you have been doing this since the 90s. And you're like, okay, there was all this new stuff, there was all this virtualization, whatever, but what is this new stuff that someone's telling me there are new things again? Do I have to care? What should I know about this? And this is why I wanted Erica to come talk to you, and I was so excited that she was able to. So probably the thing that I'm excited that you're all going to get out of this is, if you've been thinking, do I have to care? And what do I want to know about this quote-unquote serverless thing? Who can help me with that? Guess who can? Erica. Give it up for Erica.
Hello, thank you, Bridget, for having me. I also want to thank Andrew Schaefer. He's just amazing, and I worked with him some years ago as well. So yes, I am the founder, one of the founders of IOPipe. We're providing tools for developers to build and operate their serverless applications. But I have a deep history and background of working in infrastructure. I built a cloud in the 2000s, somewhere around the time that Friends was still playing. I built a cloud. And I even built a serverless platform for users in 2010, shortly after meeting Solomon Hykes, when he demoed what was basically Docker to me before it became a platform as a service and then eventually Docker again. And you know, I've been thinking about these problems for some time and trying to really get to the next step of enabling our developers. I was working with Andrew at Cloud Scaling, and then from there I went to Docker. And one of the things that was really interesting about Docker was the ability to not just manage your containers and spin them up and enable your developers, but that they could be spun up so quickly and managed so quickly, right? And this is this vision that enabled serverless, right? This idea that we can spin up things really quickly and manage them, pause them, and unpause them. That container technology is vital to what serverless is, which I'll get into in a little bit more. The first serverless product that we all know, and maybe not all, but like as an industry, is Amazon Lambda, right? And this is published by Amazon, the AWS Serverless Manifesto. And I hope you can read it with the colors. But functions are the unit of deployment and scaling. There are no machines, VMs, or containers visible in the programming model. Permanent storage lives elsewhere. It scales per request. Users cannot under or over provision capacity, but what's interesting is that users cannot and do not and need not manage their capacity, right? It's not a thing. You don't need monitoring tools. You don't need operations tools to manage and operate and worry about your scale. You actually get, it scales by the request, but you also pay per the request. So you pay for every web request that comes into your service, to an API service, for instance. You never pay for the idle. You're not paying for when things are sitting around doing nothing. A good example is I had somebody tell, so we use Kinesis at IOPipe. And what it does is, it's similar to Kafka, right? It provides a stream, and you can have workers pull events off in batches and work on them. It's not that hard, right? It's actually pretty hard. But as a user, it works pretty well. And the thing with Kinesis is that if I wanted to have 12 shards, I need to have basically 12 readers to process that data. Well, if I had VMs, if I had a 12-shard Kinesis stream, then I would need 12 CPU cores to process that in the same way that I would have, say, Lambda. But that would mean, say, 12 machines running or 12 CPU cores running 24/7. And with Lambda, when I have 1,000 events, which is one shard, come in, I need one Lambda. When like one Lambda container, right? If I have 12 shards actually hot, then Lambda just spins that up and I pay for it. And if it was hot all the time, then maybe it would be more expensive. But in reality, right, we have peaks and we have valleys. And Lambda kind of solves that by only making us pay for what we're actually using. It's implicitly fault tolerant. The functions can run anywhere. They're kind of like closures. They scale and they just work. There's like, you don't have to worry about things like retries. Like if your container fails, if it freezes, that's a problem, right? If your VM freezes, it fails, it's a problem. Lambdas, they're going to retry a couple times, and if they fail, you get an error. And you build around that, right? You build around the concept of immutable infrastructure. It's baked in, right? And if you're not building to it, your code literally just doesn't work. So you know pretty quickly. You bring your own code, and this is a really key point that I'm going to get into later, is that metrics and logging are universal right. Now, I have a little bit of thing here, which is that Amazon doesn't necessarily provide all of the things that we need in this. But I think that with ecosystem tools, we get there. So, but serverless is not just a tool, right? No more than any other process or culture is a tool. There are tools, but like DevOps itself, right? Serverless is empowered by those tools. It's empowered by the people. And it's not just, oh, serverless solves all of my problems, right? Operations are still needed, but operations changes a lot. So I want to get a little bit into how it changes. Right? Serverless is not just a platform, right? Like DevOps, it's not just a platform. It's enabled and supported by platforms. It's enabled and supported by Amazon Lambda. It is also a culture. You need to adopt the culture of, I'm going to build applications this way. Or better yet, I'm not going to build applications at all. Right? I can actually achieve the thing that I want my application to do without actually writing any code. Right? And sometimes that's a really good thing because your developers aren't writing code. Your operations team isn't managing code. You just say, hey, Amazon, give me a thing. Oh, I got a thing. OK, cool. Sometimes that's better. Serverless is an approach. By the way, this one does not explode. Right? But it is new tech, right? Like SpaceX rockets, it is new tech. And sometimes it does explode, and you have to understand how it explodes and why it explodes. And mostly it's around building immutable, understanding how to build applications that run with this immutable infrastructure model. Some of it is having the right tools and processes, and again, the people and the culture of building these applications this way. Right? It's an architecture of collaboration, working together, designing and architecting, and thinking in a serverless model and not about the servers, right? Because serverless isn't, there are no servers, right? There are servers. It's serverless in your heads. It's serverless in your culture. That you are not thinking about the servers or worrying about the servers, right? So it's a community, it's a culture, it's a movement. reInvent this last year, and I'm sure it'll probably be the same this year, reInvent had a whole conference center just for the serverless track, in addition to the rest of reInvent. Like, wow, reInvent is really big. Well, we're going to do serverless year. We're going to have another conference center just for the serverless stuff. It was that big. So some of you who've been around DevOps for a little bit may have seen this already. Right? Developers don't know enough ops. Ops doesn't know enough about your developers' needs. Cloud services bridge this gap, except when they don't. But sometimes the solution is not to write code or to build infrastructure. Right? Don't build when you can buy. Build as little as necessary. And build with the minimal operational complexity, right? You actually may not need to draw the owl at all, right? Do you just need some circles, right? Like, I know that's not a snake. I'm pretty sure that's not a snake, right? We have machine learning that can actually pretty much figure that out. You're probably about to draw an owl, right? That's the point of computers where we are now. We don't necessarily need to do all of that work anymore. So think about the things that are already out there that solve your problems, right? And maybe sometimes that's enough. Serverless right now does not, you can't build all kinds of applications on serverless, but you can build a lot of applications on serverless, and every application that you do is less code, it's less maintenance, it's less operations. So developer tools are converging. Developer and operations tools are converging, right? There's a thing, I don't want to say it, but you might be thinking it, right, about the idea that operations isn't needed, right? They're needed, but they're different. And I think this goes a lot actually into Brian's talk. Oh, wrong button. Okay, so like here's your classic operational model. We have an operator, we have a developer, we have an application. Operators have tools that they use to deploy and manage the application. They consume the monitoring, and they deal with all the problems. And the developer writes an application and hand it to the operator and say, here, solve my problem for me, right? In theory, right, like with DevOps, like this is the thing that, one of the things that we've been trying to solve for some time. And say, this, like we said, this is enough. We're not doing this. I'm putting my foot down, no more, right? DevOps days. Right? So we're going to be agile. We're going to have continuous deployment, right? And it's kind of like the same thing, except that now, right, systems engineers, right, and SREs and DevOpsers are doing tools as a service. Thank you, Brian. They're doing tools as a service and providing those tools to the developers and saying, hey, here's a tool. You don't give it to me, give it to this service, and this service is going to deploy it for you. That's cool, I like that. But, right, developers are not necessarily, at least in this slide, managing or operating their code at all, right? Deployment is fast and easy, right? Operators have enabled the developers to build their application, to be agile, to ship quickly, right? Ship fast, break things, whatever. It's fine, it's good, it's an improvement, I'll give you that, right? But it's the same pattern as before, but with automation, right? Your developers need, right, like, if you're in operations, your job is to enable your developer and to support your workloads and your applications, right? And, I mean, honestly, it's better for you if your developers are, like, not bothering you. So, like, you want to enable them as much as possible, right? It's not just, sorry. Right? It's not just about enabling your developers to ship the code. It's about enabling them to manage their code and operate their code. The continuous deployment is still valuable. I may have included information from other slides. That's why I'm confused. Okay. So, I got a little bit lost here. So, there's this other model here of, okay, I'm a developer operations person. I'm going to step back, and we're going to change our culture and say, developers, you're going to look at the monitoring for your app. You are going to deal with these things, right? And you bug me when things are really bad, right? Like, I'm still here, right? I'm the operations person. I'm still here. I'm going to support you, and I'm available to you. But, hey, you're going to, manage continuous deployment. You're going to manage monitoring or whatever yourself, and you're going to DevOps. You're going to build your application. You're going to manage these things, and I'm going to help you. I'm able to help you set up the continuous deployment. I'll help you set up the monitoring. I'll make sure the databases are working. But, the application lifecycle, that's your problem, right? Like, bug me when it really breaks. Right? And the goal isn't to eliminate operators, right, but to eliminate the necessity of them for developers to get their jobs done, right? That developers can keep doing their thing without having to bug other people, right? More self-service, more self-sufficiently, developers can be more self-sufficient, right? And it returns, right, almost in a way back to a consultancy type model and support type model where operations is supporting and enabling rather than having to be actively engaged in the process in order for anything to work. So I call this, we have done a Docker. Right? Like, we're at a point now where the operations people, like, they're still there, right? I mean, I'm just not showing them in the slide. Like, you still exist. But we're at a point where developers are building their applications, and they're working on their machines, and they ship them out to the cloud directly, and it kind of works. You don't even need necessarily continuous deployment for things to work, because you don't need like build servers and things like that anymore necessarily. Right? You can still have them. But the hard requirement for them to be there to get any work done is gone, right? You know, it's a thing that you might need because you have a specific use case, or it's a thing that it's a best practice, or whatever. But it's not like the model doesn't necessitate it anymore when you have things like Docker, right? But the problem is, again, things fail, containers die, retries are exceeded, and they don't come back. Apps and containers hang. So I want to go back to the manifesto again, right? You know, the metrics in logging are a universal right. You know, if I go back a slide, actually, right? Well, not 2 slides, 1 slide. Right? You know, our operations tools, our application, our monitoring are all separate, right? Like when you're using Docker, your application is running and data is streaming off the back of it into monitoring, and then you're looking at your monitoring and you're like, okay, let's make sure we have all of the resources that we need to run this container cloud, right? Let's make sure we have everything that we need for this to run. Let's make sure that these containers are running. Let's make sure our application's running. You have all of these things. The monitoring is a huge aspect and challenge of containers. So what if we just said, we have an application and we have tools, and my development tools are operations tools. I am, like, it's guaranteed for me that my application is going to work, that my application will never hang, that my application will never fail except for, like, when I actually, you know, like, wrote some bad code. And, like, like, if you write an infinite loop, the code's not going to work. But it's not going to work, like, stop working suddenly, right? It's going to stop working every time it hits the same conditional statement in the code, right? It will consistently fail the same way every time, and it will self-recover every time. It's not like, oh, it hit an infinite loop, and now that container is dead, and we're going to, like, respawn it so that, like, we can process other workloads. No. The next request comes in, and it says, hey, I'm brand new. I have no problem. Like, let's get back to work. You know, yeah, I'll also fail if you hit that same set of conditions, but as long as you don't hit that, you know, let's say unique set of conditions, I'm going to be fine. Right? So these tools have converged. These tools are handling your monitoring. You know, it's app ops, as Brian said, right? All of your operations, all of your app development is a single thing. It may not be one tool necessarily, right? But those tools are available to developers, and it's a single process. Monitoring, tracing, profiling, debugging are part of a development process, and the runtime, and the production environment. These are things that are kind of just available to you, and you're not doing it just, you know, as like, oh, I'm going to do it on my machine. I'm going to do debugging and profiling on my machine, and the environment changes. Like even with Docker, right? Things change. Like you're running on Kubernetes, and now it's different. Right? And I think that this model is, in a way, kind of what things like Kubernetes are trying to resolve, to bring this type of model closer to the container ecosystem. But, right, there's a lot of that app stuff, right? The APM, the New Relic, the stuff, like, that's not part of Kubernetes. Like, that's a whole other system. And serverless application development brings this to you, where you just deploy your application and you know if it's working or not working, and you debug it and it's cool, right? If there's a problem, you open up your debugger So, this is facilitated by better tooling, not only by better tooling, but by smarter platforms. Lambda in particular, but like S3. Like, how often has S3, failed? Once. But like, that's pretty good. It's pretty good, right? And, you get things like, Brian said, semantic logging, structured data. It's beyond uptime and reliability monitoring. Right, this is like, I would say, a serverful application design, and it's like a platform as a service. This is Elastic Beanstalk. You have a few instances. It handles most of the stuff. It works pretty well. It's almost out of the box. Everything's working, but not entirely there, right? Like, this application is taking data and putting it into Kinesis. So, okay, that seems like a reasonable thing I need to run Elastic Beanstalk for, and like 4 instances, and have some code I have to maintain and operators, and pay my monitoring company X number of dollars per instance to monitor it. Or this is a configuration for API Gateway. It's not even an application. It's a configuration, right? It is a Swagger document. You can literally upload a Swagger document to Amazon, and it replaces all the infrastructure, all of those instances, all of that monitoring infrastructure, all of the, everything I'm paying to Datadog or whoever to do that, right? And it's not like you shouldn't ever do those things, but sometimes you don't need to do those things, right? So like, if you don't need to, why would you? In this particular case, there are questions like, well, maybe is it fast enough, right? API Gateway is not necessarily the fastest thing. It's not that cheap, although it's not super expensive, but it's not necessarily super cheap either. But when you consider that you're not paying for all these other things, it tends to be cheaper when you look at the whole picture of operations and development, et cetera. Okay, so I wanted to do some demos, and I'm running out of time. I have like 10 more minutes. So I just realized I have to hold this mic and do a demo. This is going to be fun. And get on my slides. Let's see. Can you see my, no, that's not the right screen. Okay. Okay, so I'm going to be coding on that big screen down there on the bottom of my feet. So, all right, everybody see that? Yes? Okay. Oh, thank you. Thank you so much. Perfect. Okay. I just have to look around you. Okay, good. All right. So, like, an example of something that you might run. I can hold it for a moment. Thank you. I don't want to break your arm. Right? Like cron jobs. How many here has ever spun up a server just to run a cron job once a day? Right? I'm seeing hands, right? Not everybody, right? But it's a thing that happens, right? You spin up a machine, like, oh, it runs a cron job once a day. It is not necessarily necessary, right? So Amazon offers a thing called CloudWatch Events, and they can spawn containers on Elastic Container Service or run Lambdas, right? So I'm just going to type really quick. Thank you. Okay, so this is a file. It's a Node.js application. It just exports a function, and it runs a child process of curl, because I could totally do this like with the Node libraries, but I was like, make this like a real cron job, right? Like, let's actually run curl. And this is hitting a service called like snitch, which is like a daemon man switch, and make sure that your cron jobs are running. This is literally a cron job that hits a service and makes sure cron jobs run. Right? And okay, thank you. All right. And I use the serverless framework here, and I have this YAML file, and that's pretty much it, right? I just say that it runs every 30 minutes, and I do SLS deploy, which is the serverless framework. It's a tool for building and deploying your serverless applications, and it's going to be uploaded to Amazon, and it'll be running every 30 minutes and making sure that it works. Okay. So let's see. It'll take a moment. I might actually kill it because I'm not going to do a lot of like feedback back to it. Okay, so I'm going to just kill that real quick because, trust me, it finishes uploading. Okay. Right, you can also take like Express apps, right, written in Node. So by the way, if it supports other languages besides Node, I'm just giving examples in Node. We have, right, okay, index.js, right, and we take, so this module right here, AWS Serverless Express module, and we create an Express app, and we create some routes, and we expose them. And then we create the server instead of listening on a port. We use this wrapper that Amazon wrote. And then I also have this little thing, which is like a little bit of code that I have for IO pipe that provides additional context to as logs, like semantic logs. So we're logging automatically the requests that come in, to get, if it's a GET request, what the path is, things like that. Query arguments, that all automatically gets logged based on the input to, it basically becomes middleware for Express and says all this stuff gets logged automatically. And then serverless YAML, I'm just saying we have these paths. There's actually a way of like saying all the paths, but I didn't want to look at the documentation for it, so I just wrote them all out. And then we can do SLS deploy, and we will wait for this one because we're going to get some endpoints back, and I'm going to hit them with curl. And we have like 5 minutes. We're good. We're good. We'll make it. We'll make it. I only have one more demo after this. Let's see. I know this is the boring part. We like wait for things to upload to Amazon on like a conference Wi-Fi. Actually, no, this is worse because this is actually running in AWS. I'm doing SSH into AWS, so it really shouldn't be this slow. Well, you know what I'll do? I'm going to start a new, oh, that is really small. Okay. Okay. So this is this other little thing that I use to explore Amazon. So I'm just going to check out cat functions exec. Yeah, so what this does is this spawns processes on Lambda for commands that you type in. So every time I'm going to run a shell command, it's going to run a shell command on Lambda in a new container. Okay. So yeah, so I'm typing ls, and let's see, I get back some stuff, right? So ls proc, right? I can look at proc in Lambda, right? And like this is how like I kind of dug in and found some really cool stuff about Lambda and how it works, and found exploits and reported them to Amazon. So okay. I'm going to show you something really cool after this that I promised other people I was going to show. But let's see. Wait, how do I? No, that's not what I wanted. How do I do this? Okay. I'm trying to. Oh, that's right, because I'm on a. What happened to my other console? Uh-oh. Okay, I have like 2 minutes. Okay. Okay, you just have to believe me that the Express app worked and that we can curl those URLs because I don't know what happened to it. So I need a web browser. Okay. So we can also, by the way, there is a console on Amazon for Lambda, and you can create Lambda functions on their website. The serverless framework is a lot more useful because it's a DevOps tool, and an Amazon console is an Amazon console. But yeah, here's the Express app that we just uploaded, and here's the Lambda shell that we were just using. What I want to do is log into the IO pipe dashboard, and I'm going to do this because I want to show you profiling for the Lambda shell. Because like this is what I was mentioning with like the app ops is, and these are the invocations of the things we're just running. And you can see that we never ran the Express, we never hit the endpoints for the Express app because we couldn't find it because I lost my shell. But here are the invocations we just had. We had no errors. In fact, actually, I'm going to get a command not found real quick. And OK. And like in like a second, you're going to see a command not found, or you should. I'm going to just refresh. There we go, command not found, right? So we can see those errors. But I want to go into, in fact, you know what, let's do it for the command not found. We'll go into that invocation, and you know what? Let's go into this one. Here we go, right? So here's a URL. 45 seconds. We'll make it. We'll make it. We'll make it. OK. I'm going to go to Chrome Inspect. I'm going to open up DevTools for Node. Oh, it opened on my other screen. Don't worry, 10 seconds. And downloads. Right. Right? And we can get profiling information from code that's running on Lambda. So like if I ran this on my Express app, for instance, I could get a whole profile of every single request. So I can actually search for individual HTTP requests that came into the service. Thank you. And then actually get profiling and tracing information for each of those, right? Like this is the power of doing app ops and building serverless, where we, you know, everything is per request. Everything is debugged and implemented and, you know, operated at a per request level. So, OK, now it's actually now 20 seconds. So thank you very much. It's been great. I'll be around. So bye.